Alright, hey y'all, it's Miss Summers with your notes today on air masses, fronts, and weather. So we want to know how are air masses classified and how do these air masses create fronts and how do those fronts create weather that we then experience. Alright, so let's start by looking at slides 2 and 3. There's a couple maps on here. Alright, these are some just run-of-the-mill weather maps. This one's from last year, October, about the same time last year. Alright. I want you to look at what these numbers are. What do these numbers mean? And hopefully you've seen a map like this and you're like, oh, those are temperatures, Miss Summers. All right, that's really cool. Now let's look at this one. Now we don't have any color codes on here, but we could probably infer that these are also based on temperatures. The red and orange colors probably being the warmer ones, the blues and greens being colder. So both of these maps, so it's asking what the maps here have in common. Both of these maps are showing temperature, but what I want you to note is that these temperatures are not random. All right, I want you to note that you have this line separating very warm temperatures from very cold temperatures. We had one over here as well. The line's right about here on this particular one. All right, now I wanted to show you this first because throughout these notes we're going to look at why this separation exists. What is this thing right here? Okay, so let's move on to slide 4. The first thing we're going to talk about are air masses. All right, so an air mass is a clump of air with similar characteristics throughout. All right, so it's a blob of air. Air masses have a moisture content and a temperature. That's how we describe them. That's how we're going to give them their names. And these properties are determined by where the air mass is formed. So did it form over Canada? Does it form over the ocean? Did it form over a desert? Those types of places or information about those places are going to tell us what the air is going to be like. Okay, so let's look at naming an air mass. Okay, we want to classify them. We're going to give them names so they're easier, so we can tell what they're like. All right, so the name, again, is based on where they're formed and the characteristics that go with that. Okay, so we can see here we have 1, 2, 3, 4, 5, 6, 7. So it looks like 7 different air masses. All right, each one has 2 letters. So this one's CA, here's an MP, here's another MP, CP, MT. You might see a pattern. All right, the first letter is always going to be C or M, and the second letter is usually going to be P or T. Occasionally it's A. I'm not going to focus on this one too much. All right, so let's look at what the first letter means. The first letter stands for moisture content. So is the air wet or is it dry? Is it humid or not? So C stands for continental. If an air mass has a C, that means it formed over land and the air is dry. Okay, air that's dry does not usually bring precipitation because there's no water. That makes sense. M stands for maritime. Now mar is M-A-R, that means ocean or the sea, like a submarine goes below the ocean. The Marines, like the Armed Forces, the Marines, they used to be a branch of the Navy. That's why they have that name. All right. If an air mass is maritime, that means it formed over water, usually an ocean, and it has a high moisture content. So this air will be humid, it will be wet, it will be moist. It will probably bring water with it. Okay? So if I look at my M's, here's my M's, my MP's, and my MT's. All of those are over oceans. All my C's, like my CA up here, here's a CP, here's a CT, they're all over land. Okay, so C is dry, M is wet. The second letter shows temperature. Okay, so generally there's a couple different letters. There's A's, which stands for Arctic. I really only care about T and P. All right, T stands for tropical. So tropical just means that it's closer to the equator and it's going to be warm. So here's a CT out here in the American Southwest. That would be a warm air mass. All right, same here with my MTs. They're sort of here in this tropical region like Caribbean, the middle of the Atlantic, or the Pacific, also warm. P stands for polar. All right, if you think about polar and polar bears live with it where it's cold. All right, so my CP air mass, remember C is dry, P is polar. It's over Canada. Canada is generally a cold place. Cold air comes from Canada. All right, so T is warm, P is cold. Now, using that information, let's fill in this chart that's on your note sheet. So, let's start in the top left corner, a CP air mass. Well, C means it's dry, and P means it's cold. So this is a continental polar air mass that is dry and cold. It formed over cold land. All right, let's look at MP. So M stands for maritime, P stands for polar. Maritime means it's wet, and polar means it's cold. A maritime polar air mass is going to form over a cold ocean, like the North Pacific or the North Atlantic. All right, let's go to the bottom row now. We're at CT. So CT stands for continental, tropical. So continental means it's dry. Tropical means it's warm. This might form over like a desert or a rainforest, somewhere near the equator. And our last air mass, MT, stands for maritime, tropical. Maritime, again, means wet. Tropical means warm. This is going to form over tropical oceans or warm oceans. All right, so those are our 4 main air masses. So, okay, that's really snazzy. Now, what does that actually do? Well, the reason it's important to know air masses is because when air masses meet, they don't mix. They form a boundary. Here's those maps again from the second and third slide. All right, these areas where you had this, it's kind of like a line of demarcation between hot and cold temperatures. That's called a front. A front is where air masses meet, and it's where most weather takes place. We're going to look at 4 different fronts. I want you to know the symbols. Okay, I'm going to ask you to draw a couple pictures. All right, and I want you to know what happens at each. All right, so let's first look at cold fronts. All right, a cold front happens when cold air moves in and warm air gets replaced. So the cold air is pushing in. Remember that cold air is more dense because the molecules are closer together. That forces the warm air to rise rapidly. So you have like a wall of cold air, the warm air goes up real quick. When air rises, it cools and condenses. You get clouds, and often you will get severe weather with a cold front. All right. After a cold front passes, the temperature is going to drop. So if we were to get a cold front, we would expect a line of rain or thunderstorms and then cold temperatures behind it. All right, make sure you know that a cold front looks like this symbol. It's blue with little triangles. They're like little icicles. The triangles point which way the cold air is moving. So this cold front is moving to the south. This cold front is moving towards the east. And you can see the cold temperatures behind it, the warm in front. All right. I have an article. You're free to read this if you wish. I made this PowerPoint last year. It was about this time. And it just so happened the day before there was a pretty strong cold front moving in that had been so severe it had actually formed a couple of tornadoes out in the Midwest, out in Texas and Oklahoma and Arkansas. Happened right along that said cold front. All right. All right, now let's look at the opposite of a cold front, a warm front. So a warm front occurs when warm air moves in. Okay, your temperatures are going to get warmer. All right, the warm air is still going to rise, but it doesn't rise quickly. It slides over the cold air. So the clouds will form ahead of the front with a little bit of precipitation. Okay, so usually these are like nice gentle rains. It's nothing crazy. You don't get like big thunderstorms usually. And then as soon as the front passes, you'll have nice clear skies and warm temperatures. Okay, but I want you to note the difference. Cold air, at a cold front, the warm air gets pushed straight up. At a warm front, the warm air slides over gently. All right, our third front is called a stationary front. A stationary front occurs when two air masses meet, but they stop moving. So stationary means you're not moving. This happens, you can get several days of rain or snow depending on what the temperatures are. This symbol, I forgot the symbol for the warm front. The symbol for the warm front is red because red means warm. And it has like little sunrises. I think of these as little sunrises. And again, it shows you which way it's moving. Stationary front, you have blue icicles and warm red sunrises that are linked together like so. All right. So stationary front just stays for a long time. Our last and final front I want you to know is occluded, okay? The occluded. Usually we don't talk about this much, and like you might not see this on like the weather channel. But an occluded front happens when a cold front catches up to a warm front. So cold fronts move faster. Usually they happen around areas of low pressure. We'll talk about pressure next week. All right. Warm air is forced up between two wedges of cold air, like this. Okay, so this is a good thing to draw. So here's the cold front. All right, it's catching up to the warm front, pushing the warm air up. This was the cold air that was in front of the warm front. So now the cold air is together. You can get precipitation and strong winds at an occluded front. The symbol, so because it's overtaking it, the color is purple. So it's like a mix of red and blue. And you will have triangles and little semicircles. So it's kind of like they're merging. That is an occluded front. All right, so we've gone over the air masses, where they form, and the characteristics. So warm air mass can be either dry or wet, or an air mass can be cold or warm. And then when air masses meet, they make one of these four types of fronts. Either a cold front where cold air moves in, a warm front where warm air moves in, a stationary front where neither air mass moves, or an occluded front where the cold front catches up to the warm front. All right. I just have a couple like little practice thingies on here I want to go over right quick. Cold front or warm front, how do we tell on a radar? This is a classic example of a cold front. You can tell because it is a very thin line of severe weather. All right. Cold fronts will they'll have really bad weather, but it'll be this very narrow strip right along the front. Which way is the warm front advancing? We can see that the warm front is advancing to the east. You can see that there's a little bit of cloud cover ahead of this front because the warm air is sliding up and over it. Here we have our cold front behind it. Right here where this L is, this is where the occluded front's going to happen once this cold front catches up to this warm front.